Hello guys, welcome back to my Python YouTube channel, and in this Python tutorial we will be learning very important thing in astronomy. We will be trying to study the spectra of a galaxy using FITS file astropy package. So basically the spectra of a galaxy look like that. You can see there is like absorption lines. There are emission lines going upward and some absorption lines going downward to deep. So this is the flux and this is the wavelength. So same thing we have to create using astropy package in Python. So let's do it. So for that we use we need to import some libraries. So import libraries, import numpy for taking care of arrays, or import matplotlib dot pyplot for plotting, and import astropy for import astropy for reading FITS file. Okay, so these are like necessary libraries to read a FITS file, and in my directory there is a spectra of a galaxy in FITS format. So let's read that file. So read FITS file spectra. So for that, give that file equal to, say, fits dot open and give your file name dot extension. So in my case it is arp underscore spec dot fits. Let's run it and check it what is in your file. So these things are showing. So let's get more information about that. So type file dot info. So it will give file information. See, here your file name is arp underscore aspect dot fits. We have primary SDU and bin table SDU. So this contains our data file. You can also look uh, for different. You can go for the file header, file dot header. Okay, maybe you can go for your data. So data equal to type file, and like you have 0 1 2, so you can give 0 and dot header. Maybe yeah, doing that way. So you can see that there is like information about these observations. Go from above. So you can see there is like RDEC of the object. This is telescope Sdss 2.5 inch, and so many things. You can also give, see that there is a unit of your uh, wavelength is in angstrom. You can see that your flux is in the unit of 10 raised to minus 17 arg per centimeter per second per angstrom. So these information it will give. Similarly, you can go for file 1. See, it is your flux, your log lambda, and these things have been given. So this way you can get. Now your data is in file 1. I mean SDU1. So for that you will extract data. So read your flux uh, wavelength and your redshift. So for that we type data equal to f1 file 1 dot data. Now type. So see here your flux and your log lambda. So this way you can do. Now we want your flux. Type flux equal to data and then type flux keyword. So it will give your flux. You can check it. Or similarly you can check your wavelength. So your wavelength is in like 10 raised to log data and the keyword is log lambda. So this is your wavelength. Now our job is to plot this spectra. So for that plt dot plot, simply type your flux wavelength on x-axis and flux on y-axis. Let's see what it is doing. See, you have a nice spectra here. You can close it. See here is your spectrum of that galaxy. You can see there are some emission lines, 1 2 3, there are more, and some absorption lines. So this spectra is in like moving frame. So for that we in order to observe this spectrum in rest frame, we should know the value of redshift. I mean the galaxy is at what distance. So for that redshift you can find out. Just call z equal to file2 dot data and then z. See, your redshift is 0.0288761. So this is your redshift. So you got your z value. Maybe you can, yeah. So what you can do? So basically your z should be like z0. Yeah, so you have extracted your redshift. Now you can give this spectra some title to know, like purity dot title. You can call it as a like galaxy spectra ARP 105. You can also give its X level, purity dot X level, and give it wavelength. Okay, so it has written, and your Y level is purity dot Y level, your Y level is flux, and your flux is in the unit of 10 raised to, it is in minus 17. Yeah, so flux is in the unit of, it is like arg per centimeter square per second and per angstrom. So for writing angstrom, you can write in the math mode. R, and then you can type here backslash AA, and this has come in the angstrom. So this is, you can also make the plot bigger by adding interactive control. So add interactive control. So for that, add matplotlib widget. So this has make your plot more finer. You can see your wavelength and flux. You can also give, it is in like, so just type here backslash AA, it is in angstrom. So this way we can do, maybe you can 10 raised to, yeah, that will work much better. Yeah, 10 raised to minus 17. Just you need to, yeah, so this way. So this is in like moving frame. You can type in moving frame. Now our job is to plot the same spectrum in the rest frame. So for that, you need to divide your wavelength by 1 plus z. So what we'll do, we will just type second figure plt dot figure and plt dot plot your wavelength divided by 1 plus z. Okay, and your flux will be in the same. So this you can add a cell, you can add a cell here. We give a small heading here. Type a spectra in the rest frame for z equal to 0.00, it's a 0. What was it? 0.028. Yeah, so 0.0288. Now see, the spectrum will be a little shifted. You can see, maybe you can give a color, you can give color equal to red to distinguish what happened. So this is our spectra in the rest frame. So you can also give title, so just copy paste and in the rest frame, in the rest frame. So this spectra has got the rest frame. You can also type here next rest wavelength. Okay, so I hope you have learned how to get a spectra of a galaxy in the rest frame. You can see here that you can see some lines. You can also see that your spectra is like little bit shifted. See, this spectra is beyond 900, but this is below 900. And so now we can identify some lines, okay, that what lines are present in this galaxy. So for that we'll go to this website, Sdss website, and you can check it. See, you have one line at around, you can check it, so 6.5 something like that. Now check in that, it is 6564, it is age alpha 6564.61. so you can draw a line on that to recognize. So plt dot vertical line, and where at x equal to 6564.16. Let's see, you got a line here. That means this is your inch alpha line. You can label as label equal to inch alpha, then prt dot ligand, run it. See, this is like line is inch alpha. You can also give this level equal to a spectra. Okay, so now here you can also see there is a line. It is almost coming around 3729. Let's check it. 3729. Yeah, there is like two lines. 3729.8. It's O2 line. So similarly, you can also plot for that. prt dot x v line, and then what is that? 3729. 3729.8. 379. You have x equal to 3729.8. 3729.8. 875. It's O2. It's a doublet. You can give label as O2. It is O2. See, so this way you can also change the color if you like. Color up इसको black कर दो. See, like this way you can also identify line in your rest frame of the observer. So you can identify more lines using the table given in Sdss. So basically what we have done in this spectra reading tutorial. So we have like a FITS file for a galaxy. We have read that FITS file. We have extracted its flux and wavelength. So our wavelength is in like on log 10 units. So we have converted back to the scale, and then we have find out redshift. We have plotted like original moving spectrum in the moving frame, and then by dividing lambda by 1 plus z, we have gone into the rest frame for z equal to 0.0288, and then we have plotted the original spectra in the rest frame of the observer or in the lab frame. And then we have tried to identify inch alpha line and O3 lines, O3, O2 emission lines in that spectra of the galaxy. So this is like quite helpful for like beginner PhD students or grad students for basic astronomy and astrophysics, those who are doing. So I hope this has helped you a lot to gain some insight about how to obtain a spectra of a galaxy uh, from AstroPy, Python. And if you feel that you learn something from my tutorial, then you may subscribe the channel. You can also comment if you need any query about that. So thank you. And also I will upload this code in our video description. So thank you.